What's up, everyone? Welcome to my YouTube channel. Today we're going to work on this LeetCode problem 1249, minimum remove to make valid parentheses. So this problem is currently asked by Meta a lot. So this is a medium level problem. This is a fun problem to solve. So let me explain the problem using an example here. So if we are given this string as an input, so we need to remove uh, the extra parentheses and and return the string which has only a valid parentheses. So what makes an valid parentheses? So when there is a open parentheses followed by close parentheses, it is a valid parentheses. It's a valid parentheses, and if it's there in the string, the string becomes valid. So in the example here, we have an open here. There is a close for this open, and there is a close for this, and there is a close for this open here. So the extra there is an extra close and an extra open. So Meta might ask you a different variant of this problem by giving different types of parentheses in the same string. Um, if you can solve this problem, so you can take the same concept and solve all the variants which Meta asks in the interview. So for this problem, I would recommend I would recommend you to start with a brute force solution and then go for an optimized solution. So the brute force solution for this problem uh, is to use a stack and a set to keep track of the uh, indexes where there are open and close parentheses. So, for example, let's use the brute force solution for this example. We would have a stack and um, and a set for open parentheses. Let's say extra close. So as we iterate to the string, we see an open parentheses. We would add that index to the stack. So this would be index 0, 4, 5, 6. So at index 6, we see another open. So we add that one to the stack. At index 8, we see a closed. We remove that from the stack. We remove the added open. So because we see the stack is not empty. So again, at index 10, we see another close parentheses and the stack is not empty. So we remove this one. So at index 14, we see there is an extra close. So, but the stack is empty. So we add it to the extra close. So index 14, and we would have another open at index 15, which is added to the stack. So in the next iteration, we would reconstruct a string by removing these in the indexes from the output string and return the string. So this solution requires a stack and a set. So which is an additional space, and the space complexity increases. To improve this, we can just use one variable to track the extra open parentheses. And so the extra close parentheses, we would just ignore them. So let's let me quickly walk you through this one. So we would have extra parentheses. So you would call it extra open, and this would be our string. Would have an extra open as well. So as we go, we see we would consider every open as an extra open. As we see an open close parentheses, we would decrement this open. So we would see here this is one. We would make this as one. So we one. So once you come here, we see there is another one. So we make this as two. So we come here, there's a closed one. So we make this as one. So now it's there is a one. Uh, so we make this as zero. So in the end, when we come here, there is a closed parentheses, but there is no extra open. So we just ignore this one. So when we go here, there is extra open. So there is one. So far we would have ignored this, and this would be our string for now. So when we go in the second iteration, so we go from the backwards, and we see there is an extra open, and we would decrement this to zero, and we would return this in the end. So let me start coding, and it would be more clear. So as I said, we would say extra open is equal to zero. So we would have an output. So in the end, we would convert this output to a string and return it. So we would start iterating the string every character. So if the character is equal to open, we would increment this extra open by one. If the character is closed, if extra open is equal to zero, we would just continue. We would just ignore the close, else we would decrement the extra open. So in our output string, we would just add all the characters so far. So this, if there is some closed without an open, it would be added to the output array. So if we see now, if the extra open is equal to zero, we can just return the string. So we know there is no extra open. But to remove the extra open, we iterate to the string in reverse and just remove the extra open, and we can return the output. So for that, we would say, so we are going backwards. So -1, -1. So this is going to go in backwards. So we see now if the output is equal to output of I is equal to extra open and extra open not equal to zero. So you would make this this as empty and increment the extra open. So in the end, when we come out, we can just return the string, and we just submit, and it has been accepted. So thank you.